student, you are going to compare more than two groups. For to be more specific, we are going to compare three groups. We have Vanish, Santos et al. Determined the percarbonate and carbonate percentages in Vanish. They analyzed samples taken from the top of a jar, samples that were taken during the whole dip of the jar, and samples which were taken from the bottom of the jar. And here we have percarbonate concentration in top samples, percarbonate concentrations which were taken from the whole dip of the jar, and percarbonate concentration of samples which were taken from the bottom. The same thing was done for carbonate percentages in Vanish. Well, the first thing that you have to do to analyze this data set is loaded in Commander. We go to Data, Import Data, from Microsoft Excel file. We let in here unchecked since your samples don't have numbers. And okay. Now the data is loaded in Commander. You can see your data in here. The first thing that we could do is looking for outliers. We go to Graphics, Boxplots, and we begin with percarbonate. Sorry, we must look for ash class. So we go into Graphics, Boxplots, Plot by Groups, and OK. Now we have the box plots for samples which are taken from bottom, from the whole dip of the jar, that is the mixed samples, and samples which are taken from the top of the jar. You can see that we have three different concentrations. At this moment, I can claim that percarbonate concentrations were different in the three samples. Normally, we use one-way ANOVA. One-way ANOVA, we're going to say the percarbonate concentration in the three samples are the same. No, the percarbonate concentrations in three samples were not equivalent. If the concentrations were not equivalent, you use a Posthoc test to compare the groups. Looking to this box plot, I can say the percarbonate concentrations in the three samples were different, and the three samples were different. The sample that has more percarbonate is samples taken from the top, followed for the mixed samples, and samples taken from the bottom. So I don't need to use one-way ANOVA or a post-hoc test and a post-hoc test to confirm this. However, if you are going to use a hypothesis test, we must take off the outlier samples. We can do the same observations for carbonate. We go to Graphics. Box plots, and now we are going to look for carbonates. I look in here. I can observe that the three samples had the same carbonate concentrations, but we have the outlier samples in here. Well, if we're going to use hypothesis test, we must take off outlier samples. We are going to take off outlier samples. These outlier samples were deleted in spreadsheet 4A. Now we are going to do hypothesis tests to confirm the observations that we get visually using box plots. So I will go load my data set, import from Microsoft Excel file. Just remembering that all spreadsheets that we discuss in this playlist were provided in the video description. Now I'm going to open, and I will do box plots again. Box plots for percarbonates, plot by groups, and okay. Now this sample was classified as outlier, and I can confirm in my previous claims the observations that I did before outliers take off. Before I take off the outliers, I take the same conclusion using box plots about percarbonate percentages in samples. The percarbonate percentages in the three samples were totally different. Now I will use box plots for carbonate levels. I go graphics, box plots, carbonates. Okay. I can observe that the carbonate percentages in the three samples were equivalent, and I don't see any outlier samples. If you observe the previous obtained box plot for carbonate, the box plot obtained for carbonate before I delete my outlier samples, this plot is much more clean than the plot that I have before. Well, now I can confirm my observations. I have taken the conclusion using box plots that the percarbonate percentages in the three samples were different, where carbonate percentages in the three samples were equivalent. Normally, I compare more than three groups using ANOVA, and then if the null hypothesis was rejected, I use a Posthoc test. But first, I need to know if my data is normally distributed. I go to statistics, summaries, test of normality. I go for percarbonate, Shapiro-Wilk. Okay? Statistics, summaries, test of normality, carbonates. Okay. I go to Studio Mainframe, and I can observe that the data set for percarbonate was not normally distributed, and the data set for carbonate was normally distributed. So if I'm going to compare the percarbonate percentage in the three samples, I should not use a parametric test. But I will use a parametric test. I will compare the three means, the three groups, using one-way ANOVA. I'm going to Commander. I'm going to Statistics, Means, one-way ANOVA. I will use one-way ANOVA, and I will do it for carbonates. Well, Welsh F-test not assuming equal variances. So I see if my variances were equivalent. Before I do one-way ANOVA, I do to statistics, variances, and the Bartlett test. Bartlett test used to compare variances of more than two groups. I will use the Bartlett test. And the Bartlett test say to me that the variances in the three samples were equivalent. I could say that precision of the determination of percarbonates in the three samples were equivalent. Now I'm going to Statistics, Means, one-way ANOVA, and I will use pairwise comparison of means but I don't will check the Welsh test not assuming equal Welsh F test not assuming equal variances. I know that my variances are equal, and I will use my pairwise comparison means, and I go to OK, and the results of my one-way ANOVA were provided in here in the Studio mainframe. Well, I have my one-way ANOVA in here. My one-way ANOVA gives me rejected the null hypothesis. The null hypothesis was rejected by one-way ANOVA. And my 2K test said to me the same thing that boxplots already say in the beginning of this video. The three samples were totally different. And in addition, the commander provided to me the family-wise confidence levels. I believe that samples that were equivalent will take a line in here, and just the samples that have a line inside of them might be considered equivalent. In here, you can see that the three samples are totally different. I can proceed, and since my data was not normally distributed, I can use a nonparametric test. I go to statistics, nonparametric tests, and I use the Kruskal-Wallis test. I'm going percarbonate, okay, and the results will be presented in here. And my non-parametric tests say the same thing that the parametric tests say. That the means that these three groups were different. I can do the same thing for carbonates. I can go to statistics, means, one-way ANOVA, and I will do a carbonates. The carbonates, let's say, look in here. When I did I forget the results that I take with the Bartlett test. I don't remember if my Bartlett test provided me equivalent variances for carbonate levels. So I'm going to do the Bartlett test again for carbonates. I will see the results in Studio mainframe. And the Bartlett test said to me that the variances are equivalent. So I can do one-way ANOVA presuming equivalent variances. I'm going to statistics, means, one-way ANOVA, and I will compare carbonate levels using one-way ANOVA. I go to OK, and I can see the family-wise confidence level. I will look to my results in Studio mainframe, and my results taken from my results from one-way ANOVA were provided in here. For my surprise, the one-way ANOVA rejected the null hypothesis. The one-way ANOVA said to me that the three groups were not equivalent. The three groups were not equivalent. But what kind of difference we have? The one-way ANOVA said to me that mixed samples, the samples from the bottom, are equivalent, and the samples from the top and from the bottom were equivalent, but samples from the top and the mix were not equivalent. I can say this also using the family-wise confidence level. The family-wise confidence level shows to me that samples mix and the bottom were equivalent, Some samples, top and both, were also equivalent. But samples, top and mix, were not equivalent. In here, I have the difference between groups. I have two groups that were equivalent, but I have two groups which were not equivalent. In this case, this reinforce this case of study reinforce that you might take a good visualization of the data set using box plots or plot of means, but sometimes you need to use hypothesis tests to assure your results. For example, I can compare once again the three groups using plot of the means. I'm going to Commander, graphs, plot of the means. I will do it for carbonate. And then you'll add the standard deviation. I go to OK. Well, looking for the plot of the means, I also believe that these three samples were equivalent, that these three groups were equivalent. These three groups are equivalent, looking to the plot of the means. But my one-away ANOVA rejected the null hypothesis. What means the null hypothesis rejected? The commander was saying to me that these three groups were not equivalent. The specific difference between these groups were observed using a post-hoc test. In this case, I have used the 2K test, and the results from the 2K test were provided in here. Many thanks for your attention, and please, if you like it, assign to my channel, and see the other videos of this playlist. Many thanks for your time and your attention.